Now, as per the continuation of the alkenes, now we just stopped at this place, right? At the inductive effect. Okay, my dear students, see here. When the concept of inductive effect means, what does the concept of inductive effect means? Is that after a long time, since there's lots of errors in it, right? So we were able to manage it, right? Now let's continue with the reaction part. Okay. Now see here, in the case of inductive effect, what does it mean? So that's the place where did I stop. Now see here, to this carbon, you have one alkane group over here, right? Let me write here one. Here you have two. This is a second alkane group. In the case of this guy, here we have CH3, CH2, CH2 plus, right? If you write it bigger, right? If you write it bigger, CH, H, 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 right? Be careful, right? Listen to what I am explaining, right? Listen to what I am explaining. See here. Now in this part, here you have a plus charge here. Here also you have a plus charge. And according to this plus charge, see here, there is going to be some electronegativity difference between each of these people, right? But between these two carbons, you don't have anything. When it comes to the concept of inductive effect, the electron cloud, there will be an electron cloud now. A symmetric electron cloud will be there now. This one becomes asymmetric. This one is symmetric. This one becomes asymmetric. So it pulls the electron clouds towards the carbon, and it gives all the carbon, all the electron cloud towards this carbon. It just gives a push. So this is called an inductive effect. So here also the same. As a result, this will also give an inductive effect. Once this inductive effect is in place, right? Now the minus charges will come now. The electron clouds will come towards this carbon now. As a result, this positiveness, what will happen? The positiveness of this charge will decrease. The positiveness of this charge will decrease. As a result, the more or less the positive was on this carbon, the more or less the positiveness of this carbon, the more stable the carbocation becomes. So this charged carbon is called carbocation, right? This is also a carbocation. This is also a carbocation. This is also a carbocation. So here you will have an inductive effect. At the same time, here also you have an inductive effect. Let's see over here. In this, here you will have an inductive effect. Same way, here also you will have an inductive effect from hydrogen to this carbon. Once you tend to transfer this to this side, here you have one more carbon here. So here also it will give a push, but the resultant won't come here because some amount of this effect will be differentiated. It will be different. There will be a difference within this carbon. As a result, the amount of electron clouds that has been pushed between these two alkyl groups will be much less than this. In short, the number of alkyl groups that is surrounding this carbon, if it is increases, then the inductive effect will increase. Understood? If the number of alkyl groups, so this is an alkyl group now. This is also an alkyl group now. Understood? This is also an alkyl group now. So, irrespective to the number of people here, irrespective to the number of people, see the number of alkyl groups attached here. See the number of alkyl groups attached to this carbon here. The stability of this carbon is much less than this carbon. By the positivity is much high. Once you compare this, depending on the stability only, Markovnikov said to which hydrogen it is stable, that place only, to which carbon that the stability is high, on that place only what will happen? On the either side, the hydrogen has to be given. So according to this, according to inductive effect case, the stability of CH3CH plus, then CH3CH2CH2 plus, the stability is high. Reason is the number of alkyl groups attached to the carbocation is the predominant factor. Is the predominant factor. Understood? So this is going to be your predominant factor in this case. So once you give the hydrogen over here, the positiveness will decrease. So therefore, right? Therefore, the major product, depends on, right? The major product depends on the stability of carbocation. It depends on the stability of the carbocation. So that's the main part. So whose stability is high? This fellow's stability is high than this. As a result, the major product for this reaction, for whom? For this reaction, if you put HBr, the major product is going to be CH3, CH3, Br plus there will be some amount of this fellow also, but we'll give a name for him as minor product. So this is the major product. This is the major product. This is going to be a minor product. Understood? So what Markovnikov said? What Markovnikov said was the hydrogen must be attached to the person, to the carbon, which has high amount of hydrogen. Here the highest amount of hydrogen is over here. So therefore, you will get the major product over here. Understood? Right? So very easy concept. So the places where you are going to do hydrohalogenation, right? Hydrohalogenation. Instead of using the word halogenation, you can say the word hydrohalogenation, right? So this is the most preferred word, I think so, because you are going to give the hydrogen as well as the alkyl group to the not alkyl, the halogen to this alkene group. Understood? So this is the main thing that you know. So the product that came here was actually against this rule. So there's a rule called anti-Markovnikov rule. Anti-Markovnikov rule. Rule. But this is the minor product. Let's say if you want to make this one as a major product. Let's say you want to make this one as a major product. What you have to do is take the same person, right? Add HBr and organic peroxide, or you can use hydrogen peroxide also, no problem. Organic peroxide, but most probably they'll give you this one. If they give, use this one, right? If they give you, use this one to give the major product. CH3, CH2, CH2, Br. So this is going to be your major product plus CH3, CH3, Br. So Markovnikov said the person who has higher amount of hydrogen, the carbon which has highest amount of hydrogen, will be given the hydrogen according to Markovnikov rule. Against the Markovnikov rule means anti-Markovnikov rule means the person who has less amount of hydrogen, the carbon which has less amount of hydrogen, will be given the hydrogen. Right? So that is the main thing that is going on over here. So you need to add the special thing to the organic peroxides. So you have to note this one very much carefully. So this comes under anti-Markovnikov rule. But here this becomes the minor product. So here this is the major product, right? So this is the major product. This one is going to be a minor product. This is going to be a minor product. Understood? So this is the reaction based on the alkenes. Right? Let's go to the next reaction of alkene. Right? Right. Now let's go to the reaction. Next one. Now finish hydrohalogenation. Now let's do halogenation. Let's do halogenation. Hydrogen and halogen. Now last time we did hydrogen and halogen. So here the reagents that you have to put is CH3, CH double bond, CH2. If we use Br2, keep in mind you have to use CCl4, a non-polar solvent. And if you put this under reaction under the mixture, you will get CH3, CH2, Br, then you have Br. This is what you get for halogenation. If you put Cl2, here Cl will come and Cl will come. Alright, got it? Now halogenation is over. Now we have to do hydration. Hydration. Hydration means you are adding water. You are adding water to an alkene. For this, you took this fellow. If you put dilute H2SO4 and H2O, right? Dilute H2SO4 and H2O. Same case, you have to use not anti-Markovnikov rule, Markovnikov rule. If you use Markovnikov rule, because in water you have H and OH here, so you're going to give H to one person. So you will get a carbocation over here with plus and another one person with the plus. So therefore, the major product will be the same. The major product will be same as it is, but instead of this, you will get what? OH. So that's the thing you're gonna get. So the same concept. Your major product is going to be CH3 OH. So this is going to be a major product for the hydration. Now, there's one more special case that you have to know. Using basic medium, under basic medium using potassium permanganate. What happens to these people? What happens to these people? Right? If you use CH3, CH double bond, CH2, if you use under basic medium potassium permanganate, obviously you will get a compound which looks like this. Right? A compound like this. So this compound, what we would say is a diol. A diol. Right? Diols mean there are going to be two alcohols here. Right? So we're going to have diol in this case. Right? Understood? Hope you guys understand. Bayes test. Right? The other name for this using this reagent is called the Bayes test. Right? This is used to identify the potassium permanganate oxidation. Right? Like you're putting OH to these people now. So you're preparing diols. So this is called Bayes test. So you can also do this to identify aldehyde also, but you don't need the case what is happening here. You can use this one for aldehydes also. Right? This is also happening for aldehydes. So finally, alhamdulillah, we finally completed the alkenes part also. Right? We finally completed the alkenes part also. Now we are going to start with the alkynes. Right. Now we're going to start with the alkynes. We'll start with the alkynes. What all properties were there in the second one, the alkenes? The same, everything will be there for the alkynes also, right? There is no any change. Whatever was there will be here. So we'll directly go with the reactions. Now I wish now we are running out of time. So what I will do is we will quickly go with the reactions only and see the properties later, inshallah. So we will go with the reactions first, right? So the properties are actually the same for the alkenes also, for the alkynes also. Now we will go with the reactions of alkynes, right? Now we will go with the reactions of alkynes. Reactions of alkynes. Within the reactions of alkynes, what all we wrote will be there, but the problem is some reagents will be different. So we start with hydrohalogenation, right? Hydrohalogenation. Now let's go with hydrohalogenation. Let's go with the hydrohalogenation. In hydrohalogenation, right? In hydrohalogenation, if you take a compound, right? A compound. If you put HBr or let's say HCl, right? Let's say HCl. According to the Markovnikov rule, again don't forget, right? According to the Markovnikov rule, the products will be determined. So what is the product you will get? CH3, CCl, Cl, CH3. This is the product that you are going to get, right? This is for the hydrohalogenation part. Okay, but all concepts that I explain you will be there. The same for these people also, right? Alhamdulillah. Right. Let's go with the second reaction. Now, second one is halogenation. Obviously, halogenation. In the halogenation part, if you take the same person, CH3, C triple bond CH, and if you put Br2 under same condition, CCl4, here in the alkenes you got two Brs here, right? The same mirror will be there on the opposite side. So your product will be like this: CH3, C, C, Br, 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 Br. Guys, sorry, there's one more thing I have to explain you in the alkenes. There's a thing called hydrogenation. Hydrogenation. In the hydrogenation part, CH3, CH double bond CH2. If you add any of the metals here, right? Any of the three metals that I give. So you can put H2 gas with platinum, H2 gas with nickel, or H2 gas with palladium, PD. You're gonna get an alkane again, right? You're gonna get an alkane here, right? So this is the thing that you're gonna get. So halogenation. So let's go with hydrogenation. I might forget maybe hydrogenation. So in the hydrogenation, once you take CH3, C triple bond CH, and if you put H2 PT or H2 palladium or H2 nickel, if you use any one of them, you are going to get CH3, CH2, CH3. Right? CH3, CH2, CH3. This is for hydrogenation. Let's do hydration with this fellow. Right? Hydration. For this one, right, there's a special case. Special reagent that you have to use. For this one, you have to use dilute sulfuric acid along with HgSO4, mercuric sulfate. If you use this, you are going to get CH3, C double bond O CH3. You will ask me how it came. See here, CH3, C triple bond CH. Right? You want to supply water. So according to Markovnikov rule, the H will be attached to this hydrogen, and over here you will get a OH. Here already hydrogen is high. So if second time hydration will give OH over here. I think you got the point, what I say. So you will get a product like this, like CH3, C, OH, OH, CH3. This is going to be your intermediate product. Understood? This is going to be your intermediate product. Now what will happen is there will be a dehydration process. Right? This OH and H will join together and they will remove as water molecule. As a result, already lone pair is there. It will become minus now. This minus will be suppressed by bringing pair towards this carbon. As a result, the carbon's octet rule will be fulfilled. Here there will be a plus. So this plus has to be avoided in carbon. So for that case, oxygen is already oxygen rich. So he will electron rich. So what he will do? He will transfer the lone pairs towards this carbon. So therefore you will get double bond. So as a result, you will get this fellow. Understood? But see here, if you use the same reagent for this guy, right? Keep in mind, if you use this same reagent for what will happen is you will get CH3, C double bond O H. So this is an aldehyde. This is a ketone. There is a statement question also regarding this. Regarding this reaction, there is also a statement question, a very easy statement question. If you know this thing, you can do it, right? Without any doubt. Right. Hydrogen halide. Now see here. Now there is another plan I am going to do. It's there in the resource book. I can do a preparation of alkene using alkyne. For that, what I can do? This is a very specific reaction. So again, hydrogenation. So just write in bracket two alkenes, right? Two alkenes. I brought this one to alkane. Now I'm going to bring this one to alkene. For that, my dear students, see here, CH3, C triple bond CH is there. Okay, C triple bond CH is there. Now, what I'm going to do is, I'm going to put H2 palladium, right? H2 palladium. I want to put some barium sulfate, which now is poisoned by quinolin. Right? Understand how I memorize this? H2 palladium, barium sulfate, poisoned by quinolin. Right? This is a poisonous catalyst. It won't allow the reaction to further proceed if you put this reagent here. As a result, you will get CH3, CH, double bond CH2. You will get an alkene, right? You will get an alkene over here. Now comes the special case. I want you guys to note down this one in the special point also, right? Now see here, ma. Now see here. This is an alkyne, right? This is also an alkyne. This is also an alkyne. Okay. Both of these two are alkynes. Okay. Even though if these two are alkynes, there is a special property going on over here that you should know. Here you know this is sp hybridized. This is also sp hybridized. So this hydrogen is termed as the terminal hydrogen, right? In this case, we will mention this one as the terminal hydrogen. The electronegativity of this carbon and this carbon is going to be high, right? Because it is sp. The hybridization is sp. The charge is also high in this case. It is low in this case, right? It is low in this case, but it is high in this case. The ability to remove this group is much less than this group. So you are going to remove the hydrogen, which may produce an acidic hydrogen. So in short, you can say this compound is completely acidic in nature. This compound is actually acidic in nature. How? If you put this one in water, it will undergo a partial reaction. You will understand this once you study chemical equilibrium, right? This will undergo a partial reaction which will give CH3 C triple bond C minus plus H3O plus hydronium ion. This hydronium ion is acidic. Understood? This hydronium ion is acidic. Since this is acid, now if I take this guy and put sodium solid, let me put some sodium or soda amide. You will say this sodamide. Sodamide. If you put these people, if you put sodium, you will get CH3, C triple bond C, Na plus or minus. You can even though you can neglect the plus or minus here. Plus, if you put sodium, a metal with the acid will give you a metal salt along with the emission of hydrogen gas. That's what you studied in the O-level class and all. If you put sodamide, this hydrogen will be given to this amine group, and this sodium will be attached here, which results in the formation of ammonium if we use sodamide. If you use O levels and the A levels. For this one, you can use Nessler's reagent test or red litmus test and all. Here you can use burning incense sticks, so it will put a popping sound. It will emit a popping sound. So all these tests can be identified. So which may result in saying you that this particular compound had an acidic hydrogen. This alkyne has acidic hydrogen. There is one more way to do. There are two ways to do a test. Now to identify this, there are two tests, right? One, you can use, right? Let's write this as identification test, right? You can use this one for to identify the presence of alkynes, right? Acidic alkynes. Identification test of alkynes. The first test is using of ammonium hydroxide and AgNO3. If you use this alkyne group, acidic alkyne group with this ammonium hydroxide, you have to write this. They are not basic, right? Ammonium hydroxide and AgNO3 equals, you will get CH3 C triple bond C Ag, right? Which is a precipitate. The precipitate color is actually white in color. This one's precipitate color is white in color. Understood? This is one way of identifying the acidic alkyne. Otherwise, you can use one more. So, ammonium hydroxide, right? Copper 2 plus aqueous solution. You can say this one as copper tartrate, right? Copper tartrate. Copper tartrate, right? Copper tartrate. So CH3 C triple bond CH. If you use copper tartrate, right? CuNH3 4 times 2 plus, it will give you CH3 C triple bond C Cu, which is a precipitate again, but the color is going to be a brick red precipitate. This is a brick red precipitate. This is a white precipitate. Understood? So this is going to be your precipitates for the following alkyne identification. So finally, we did a lot of tests and the reactions based on the alkynes, and finally we have completed the reactions based on alkynes also. So alhamdulillah, finally we were able to complete the hydrocarbons reaction and all organic reactions and all, right? We finished alkynes reaction also. Understood? Right. Now we have finished the hydrocarbons part, right? Exactly, we have completed the hydrocarbons part. So very much important area. Now we will move with the alkyl halides. Now we will move with the reaction of alkyl halides. Okay. Now we move with the reactions of alkynes, alkyl halides. So hydrocarbons is over. Now we have alkyl halides. So in the reactions of alkyl halides, one is formation of alcohol, right? The first reaction is going to be formation of alcohol, right? Formation of alcohol. So alkyl halide means, let's say CH3, CH2, Br. It can be Cl, right? It can be Cl or Br. If you use NaOH or a strong acid, a strong base, aqueous KOH, right? Or aqueous NaOH or KOH, you're gonna get CH3, CH2, OH. Okay, you want to get this one. Second one, you can eliminate an HBr, right? You can do this one as an elimination reaction, right? So converting the alkyl halides to alkenes. This is also an interesting part, right? This is also an interesting part. Now you have CH3, CH2, Br. What I'm going to do is going to use alcoholic KOH. You can use this one in exam as alcoholic KOH in this manner. No harm, right? Alcoholic KOH. You can use any kind of alcohol, right? So alcoholic KOH. What will happen is here one hydrogen and here this Br will be cancelled out, right? You will get this alkene. This again happens according to the Marconic rule, right? Here the person who has highest amount of hydrogen will lose the hydrogen with the halide. So this we are going to remove the HBr to form the alkenes in this situation, right? We are going to remove the HBr to form the alkenes in this situation. Third one, now you can make cyanide, right? Nitrile group, right? You can form a nitrile group. So you can form a nitrile group. What you can do is take this fellow and add potassium cyanide. You will be forming a compound named CH3. They haven't given you kind of reaction, so I'll give you in this case itself. If you take this cyanide, right, CH3, CH2, Cn, water, H plus water, and what will happen if you use lithium aluminium hydride? These all are reducing agents, a very strong reducing agent. Understood? These are very strong reducing agents. If you use this, what's the product that you're going to get? So the product that you're going to get by using H plus water, it is none other than CH3, C double bond CH3, CH2, C double bond OH. So you're going to get a carboxylic acid just by using acidified water. You can use dilute H2SO4, dilute HCl and water to get carboxylic acid. If you reduce this, it will go below the cyanide to form amines, right? You will get CH3, CH2, CH2, NH2. So this is the thing that you're going to get once you oxidize this one to carboxylic and once you reduce this using lithium aluminum hydride. The reason why using lithium aluminum hydride for cyano is there is a triple bond. between the carbon and the nitrogen. So in order to break the triple bond, it isn't easy to use a normal reagent. So you can use sodium monohydrate, but that isn't enough to break this. But the best one to reduce this cyano is actually using of lithium aluminium hydride. Okay, so this is the formation of nitrile in this case. Fourth one, preparation of Grignard, a very important fellow. Preparation of Grignard reagent. Grignard reagent. If I use the same CH3, CH2, the reagent that I am going to use is magnesium diether. Magnesium diether. Magnesium diether. The reason why I am using diether is, if I prepare the Grignard over here, all of a sudden, if there is water, there will be an issue. So the Grignard product is going to be like this, right? Let me write the product over here. CH3, CH2, MgBr. This can be new for you all. Don't worry. This can be new. I'll explain you why. If we use wet ether instead of dry ether, what happens is CH3, right? CH2, and you have MgBr, right? What does water do is, this bond will break towards the hydrogen, right? So here you have a plus and here you have a minus, right? Magnesium is going to be plus, carbon is going to have minus, the electronegativity difference. This lone pair will go to this hydrogen, which will form CH3, CH3, an alkene, plus magnesium hydroxide bromo, right? Magnesium OH bromide, right? You're going to get this kind of product. So what is the desired product? We want this product, but if you use wet ether, this will be your product. So we need this one to be done under drier condition. This will make lots of issue by interfering. If water is there, if anybody who is able to donate a proton, means an H plus ion, if they donate a proton, there will be an issue with the Grignard reagent. So the Grignard reagent has a lots of use. The Grignard reagent has a lots of use. So once you are doing a reaction with Grignard, you should keep in mind that there is a precaution that you have to take. So you should know with whom it reacts, right? With who all it reacts, right? You need to know with who all it reacts. So as I said you, we have alkynes, right? We have alkynes. R, C, triple bond C. I am using R instead of the alkyl group. Let's say CH3, CH3. R can be CH3 group or CH3, CH2 group. It can keep on going on. No harm. So if I use Grignard, let's see, CH3, CH2, MgBr. Let's say if I'm using this fellow, Grignard reagent for this guy, what happened is it forms R, C triple bond C, MgBr plus, here one H is there, this will go with this, it will form CH3, CH3. Okay. But if I use ROH, if I use alcohol, what will happen is I will get this hydrogen will go with this ethyl group and this R will join over here. So what I get? I get R O MgBr plus, right, CH3, CH3. If I use RBr, here I don't know. If I use RBr, this Br will go towards this MgBr. This R will go towards this guy. So this is plus and this is minus now. This is already minus, as I said you, right? This was already minus. This is already plus. Here it will try to get the log by this bond will break towards this alkyl group. This bromine will come towards this magnesium bromide. So you will get a alkane along with MgBr2. Okay. If I use, let's finish the part. Let's see if I use carboxylic acid. So this H will be given to this guy. So you'll get R C double bond O MgBr along with CH3 and CH3. Understood? This is what you get. So another one is RNH2. If I use RNH2, what I will get is R CH2 CH3 sorry RNH MgBr plus CH3 CH3. Here one proton will be donated. H plus will be donated. Same case will happen for amides. Here one H will go. It will form RC double bond NH MgBr plus CH3 CH3. So this is the case happens once you use all these people under this condition. Okay, under this condition, if you use these people, this is the problem that you will be getting if you do this. Understood? So this is the preparation of Grignard, right? And the use of Grignard. Okay. So here, keep in mind, even water, ammonia, phenol, right? Phenol. Yeah, all these people will also have the effect in the Grignard reagent, right? All these people will have effect in their Grignard reagent. So they will give different products, right? They will give different products with respect to these cases, right? So this is the thing that you have to know. So finally, there are certain important points that has to be discussed. I'll be explaining you at the end of this reaction part, right? There's a lot. There is around 6 or 7 points that you have to know. So by the way, Alhamdulillah, we finally again completed another completely done with it. Next is the alcohol, aldehyde, ketone. And if you finish alcohol, everything will move quickly, right? The reactions becomes less once you reach over here. All the reactions will become less. So what we will do is we will stop the class. Now we'll stop and we'll stop 2:45 inshallah. Right? So stay tuned. Share this link with everybody else inshallah. Assalamu alaikum.